Adit sir,
Yes.
I had a question. A couple of folks, they want to learn machine learning and they wanted to know, can they join at this point of time or it is too late for them to join?
See, they can join, but the point is it's not machine learning. This is deep learning. So machine learning have, several other things as well. I am specifically targeting deep learning.
Okay, okay.
So
So our basically course content is mainly focused on deep learning part.
majorly for deep learning part. Deep learning is actually one machine learning technique. So in machine learning, there are multiple other techniques as well.
Okay, okay. Thank you.
Okay.
Yeah, I think we can get started at say 8:10 already.
Okay. Wait, just have to clear a few things.
Sure, sure. I think last week we Dux has taken lab on Keras and TensorFlow.
Yes.
Yeah.
Yes. Today we are going to start a new thing. That is, I'll talk about that.
Sure.
So Manoj sir, one thing that I wanted to say is that if anyways, you are, I guess, that recording the sessions. Is that correct?
Yes.
Yes, my point is that these slides and other things, whatever the YouTube tutorials or slides, they are not being made by me. So I have taken this stuff from multiple resources. So if we are, somehow distributing or making it publicly available, then you will have to ask me that what are the credits that one should have to write. Because
Okay.
every slides credit. So in this lecture also, I'm going to take slides from another course at Stanford. So slides are actually coming from there, or sometimes I used to refer different types of YouTube lectures. So if it's going to be publicly available at any point of time, my suggestion is that you just discuss with me. So I will tell you that what are the resources and the credits. The credits one should have to be given to those guys for making the stuff. We have just copied it.
Sure, sir. Sure.
Okay. So let's going to start about now today's session, and I hope that three guys have joined. So we are going to start about this. Till now, what we have seen. So we have seen two things. First, we have talked about fully connected networks. Then we have talked about convolutional neural network. These are two things we just have talked about. I need to just just wait a minute, Daksh. So I'm sorry, I have to connect to this very important call. I hope that all of us are here. Yeah, you all can hear.
Yes, sir.
Yes, sir. Good. So yeah. So till now, what we have seen is that we have talked about fully connected network, and then we have talked about convolutional neural network. Let us first understand the main difference between them, and then the pros and cons of them, and then we will go on to talk about a very specific, special type of neural network that is actually called as the recurrent neural networks. What is a fully connected network? We all understand that we are going to have certain amount of data. This is actually a one-dimensional type of data. If you have, and then you have certain layers which are coming in between, then you have multiple other layers coming, and your network is actually being seen like this. And in this, the main thing is that every neuron is actually connected to every neuron, every data. This is my x1, x2, x3, x4 and x5, five-dimensional input. This is my neuron number 1, then the neuron number 2, then the neuron number 3. And each and every neuron is actually connected to every other data point, whatever. And then here also you can say that the final layer is also actually connected to, so this neuron, this is my neuron number 1 and neuron number 2 of my last layer. And you can say that this is my output, this is my input, and this is my hidden layer. And I guess that we all have actually done this and train different types of network. It can be deep, it can be different other concepts which are going to come in between, but essentially you are having a one-dimensional data, 1D data, and over that you are applying multiple layers. And then what is going to happen is that applying multiple layers, at last you are doing a decision. Now let us talk about our second type of neural network. This is my second type of neural network in which I'm having an image, and this image is typically m cross n size image. One can say m cross n size image, and over that what we are doing, is that we are applying over that what we are doing is that we are applying two-dimensional filters. These are actually 1D filters. Here we are applying 2D filters. 2D filters are like 3x3 filters, and then you apply multiple 3x3 filters over this, and from this, once you apply this one filter over this, then you are going to get one feature map. And if you apply multiple such filters, you are going to have a multi-dimensional multi-depth feature map. And then you do max pooling, and then you do normalization, and then you again apply multiple filters and so on. And and what will happen that in this process, your input image, this is my input image, the input's image spatial resolution keep on reducing. If suppose that it is m by n initially, then it may become m by 2 cross n by 2. Later it becomes m by 4 by n by 4, and this is happening because of our max pooling. And at some point of time, you will say that your image is actually of just 2 by 2 or 4 by 4 or 8 by 8, and you assume that it's not having that much amount of spatial information, so that you apply any spatial filters, 2D filters, then you flatten it. And once you flatten it, then actually it becomes exactly the just we have talked about the fully connected network. Till now, if there is anyone who is having any doubt, then you can ask. This is a major difference. In 2 to 5 minutes, I just have talked about both of them. If you have any question, then you can ask. I guess that everyone is okay with this. So let us go and now talk about another type of thing, which we used to say as the IID. So in machine learning, when I say that I have a data, this is my data. Overall, this data we divided into two parts. First part is training, and the other part is testing. So given any training and testing data, given my training data and my testing data, I train my network over my training data and test my performance is going to be tested, how well I am performing over my testing data. There is one more thing, that in this training we divided into two parts. First one is the training, and the other part is actually the validation. So this training itself is actually being seen as two parts. Part one is actually training, and the second part is actually, one can say, as the validation. So actually you are having two things. You are having training, then you are having training, then you are having you are having training, you are having validation, and you are having testing. Three things which are actually being there. So while training, you train your data over training data set, and in between, after every epoch or every iteration, you may check over how well you are performing over validation set, which is going to tell you that how well you can perform over the data that you have not seen so far for your training. And you keep on updating it in such a way so that you started to perform very well over your validation set. Once you perform very well over fine over your training validation set, we can say that now let us test over my model on my testing data, and I started to get my results. This is the general process in which we are going to train our model, any deep learning or machine learning or any type of model. Now I'm going to talk about a very important concept that is called as IID. IID means that first I is actually identically and independently, and this is distributed. This actually says that independently, identically, independently distributed samples. What does it mean? It means that my training data, or whatever the data that I have got, all this data is having multiple data points into that, and all of them are identically, independently distributed. Now assume that this is my whole world of data. If I say that I wanted to say the face images, then in whole world, all possible images of faces, you assume this, which I have shown it over here. It's an infinite amount of set. Out of that, I can only choose few of them, whatever the way I am collecting my data, and that is going to be my data. that we are saying that this data and this data is actually same. How I have chosen it? So you are going to sample points from this to populate your data. So this is actually, we are sampling some points out of my word or the total data that we can have, all possible data. How we are sampling? Sampling has to follow identically independently distributed, which essentially mean that if I choose this image and if I choose this image, the probability of choosing any image is there is no bias. Every data is independent as well as identically distributed. So our assumption is that it doesn't matter that if you choose this or if you choose this or if you choose this, because choosing any data from my word, it's actually independent first of all, and they are identically distributed, which essentially mean that choosing any data is actually equally probable and identically distributed. The independent means that if I choose this, it doesn't matter that if I choose my next data as this or next data is this, probability is not going to be changed. Now this is something which is essentially required. Otherwise what will happen, that suppose that you wanted to talk about the why COVID-19 is performing in a specific way, then probably what will happen, that if you only bias your information or your model is only have seen US data, then probably you may not be able to infer very well. So you will say that instead of that, I have good amount of data from US, good amount of data from Italy, good amount of data from India, good amount of data from China, and for all of the countries, if you have got good amount of data, then it is actually identically distributed, and then whatever you are going to say, that is better going to be generalized. So that is actually IID samples. And just because of the fact that if it's an IID samples, there is something which is going to happen in both of these networks, fully connected and the CNN, which we say as the convolutional neural network. What is that? Now assume that I have a model over here. This is my model that I have designed and trained over my this training data. Over this I have trained my model, and in between for every epoch I am checking that how well I am performing over my validation set. Once I feel that I am performing very well, I fix my model, and this is my trained and now fixed model. I have trained it and now it got fixed. I have got this model trained. Now suppose that I take another image. I don't know what is there. Suppose that it's actually a cat image. I send it this image to my network, and you are going to get an output. Output is going to be a dimensional vector, some dimensional vector, which is saying that with what probability this is cat or dog or mobile or car or hat or whatever. Now the point is that this cat image, I assume, I say that that is my I dash image. Suppose that if I show my I dash image to my model right now, you are going to get an output vector, say O dash. Now, after 2 days, my model is fixed, model is not changing. If I take same cat image, and take it and show it to my network, what you assume? That what is the output? Are you going to get something which is O dash, or it is something which is different than O dash? What is your assumption? What do you feel? Can anyone say? Do we understand the problem? Can anyone want to say that
We'll get the same, I think.
yes, we are going to get the same, exactly same. And the reason is that why you are going to get the exactly same thing is that this is actually a fixed function or fixed mathematical computation. It's actually a deterministic model, and whenever you take this I dash, show it to your model, you are always going to get the same O dash. And if it is going to be the same O dash, this is actually the type of model, the way in which my FC and my CNN networks are performing. Whenever, whatever, it doesn't matter that at what point of time you are showing your data, in the morning, in the evening, in the day, in the night, 2 days earlier, 2 days after your first appearance, or you are showing it multiple times in a day, doesn't matter. Every time, whenever, if your model is fixed, it is not changing. If you keep on showing same data, same output is going to come. And I assume that we all actually wanted also the same thing to happen, that it should not be the case that if I show a cat image, tomorrow it started to say the same cat image as that it's not a cat, it's actually a dog image. So that is the reason, that is actually IID, identically independent distributed samples are there first of all, and your model is somehow trying to understand that I should not be dependent upon that what you have shown me previously. Every sample is independent. So if you show me cat right now, I will say cat. Next time if you show me a dog, it doesn't matter that what you have shown me previously. Instead of that, I continuously look on that what you are showing currently. It completely don't depend upon my previous input. So if you understand this stuff, that's the base. That this is the reason that you have designed deterministic networks. But it may happen that given the input, model remains to be fixed, but given the input, my model behaves in a different way. To the same input, my model is behaving in a different way. Why? First of all, let us understand that why do you want such type of model, which actually right now to a cat image it will say something else, and tomorrow if I show you a cat image, you will say that, oh, it's something different than cat or some other information. Now let us see that there is our assumption is that data is not having any dependency. Now suppose that there is some dependency which is there in my data. If I say that today in India total COVID count is 560, can you predict that what is going to be the tomorrow's count? So you will say that one way is that you do not tell me the history till now and just say me that what is the tomorrow's count. So that is one type of prediction that you can do. You're fully connected network. But suppose that another guy will come and say that, can you tell me the little amount of history, that what is the country, what has happened till now in this country, and accordingly I can tell you that what should have to be my prediction. So in that case, you and the point is that we all know and we can agree that if I know the history, I can do forecasting predictions in the best possible way. And in this way, whatever happened till now and what current input, what has happened till now and what is the current input, both of them are going to determine that what is going to be the current output. In fully connected, what is the current input is directly going to determine what is my current output. In certain types of network in which we feel that there is some sort of relationship existing between the current data and the previous data, we somehow managed a history, and along with that history and my input, both of them are going to determine that what is the next output. Now, yes, anyone want to say anything? Is this okay to everyone? This is the point that we are now going to focus on. So that is why probably I guess that most of some of you are from US, but you may be aware of some Indian movies. So that is why I every time used to call this CNN as Gajni. Gajni. This Gajni is the guy who was not having any memory at all. So whenever you show an image, it doesn't matter that what you have shown me previously. I continuously assume that the data is going to be independent, and every day I have seen this data and I'm going to perform that what it has to be. But there are certain problems like in NLP, natural language processing, like in case of forecasting. Suppose that if I'm saying anything in language, whatever I'm saying, it is completely dependent upon whatever I have said till now. I should not be out of context. According to the context everyone is talking, who is going to manage this context? So that is why I used to call recurrent neural network, RNN. And this RNN guy, I have associated this guy as several times I used to call it as Virat Kohli. I don't what's the spelling? Kohli, Virat Kohli. So why I used to call RNN as Virat Kohli? I used to call this RNN as Virat Kohli because it has huge amount of memory along with it. Suppose that right now you meet Virat Kohli and you say that I wanted your autograph. You see the network remains to be the same, your data remains to be the same that you want, You want the autograph, and Virat has given you a nice autograph and also clicked a picture with you, and you got happy that this guy is very good and we all are happy and he is our captain. Next day, what happened? That India lost and Virat was not able to perform well. And in the airport, again, you meet the same guy, same question, that can I have a photograph? He just bang you and say that no, you cannot take the photographs. I've completely breach of my privacy. Point is that same data output is not going to be only determined by the data. It depends upon the context. The same cat image in a different context can be used or can be giving us some different information. And if that is the case, then my FC networks and my FC networks and my CNN networks, they are not able to capture this thing because they are completely not aware of the previous things. And the simple reason is that they do not have any memory at all. No memory is there. And here in a recurrent neural network, why he belongs, why Kohli can perform in a specific way? Because it's actually a human behavior. The same behavior in language. Suppose that if you see a word, sometimes the next word is going, every time if you see the next word is not going to be a specific thing. In your input is the, and your output is what should have to be your output? The next word. So if you are predicting, then after the, every time you are not going to get the same thing repeatedly. Instead of that, you need to somehow understand that what is the context, and along that context you can predict that what is going to happen in the future. So in this context, if you all understand that what is the pros and the cons of my fully connected in the CNN and what we are expected to see in our recurrent neural network, then we are going to carry forward. If you wanted to ask any question, you can ask. No questions? Fine. So let us go. So this was a brief introduction. These slides are anyways from the CS231 lecture series. So I don't claim that I have I've created these slides. Anyways, the names and other things are written over there. Yes. So let us see this vanilla neural network. Vanilla neural network is a fully connected network in which this is my input, in which this is my input and this is my output, and there you can see that there is no relationship at all. And then wait, view single, yes. And then let us see that this is my input and these are my outputs. So you see that one input and multiple outputs. That's why it's called as one to many. Then multiple inputs and one output, multiple inputs and only one output. So you can have multiple inputs and one output here as well. Then you can have many inputs and many outputs, and then you can have many inputs and many outputs. Both of them are two different things. We'll talk about them one by one. But first you see that why this was vanilla neural network, because input is directly converted into output. Now see that along with that, if I say that not only input is going to be converted into output, this state, some memory is here, and this is actually the feedback that we are going to talk about. And this is the some history or the context or the information that we have seen till now. So that assume that that is H. So in vanilla neural network, your output is going to be the function of your input, but in case of recurrent neural network, your output is going to be a function of I as well as H. I guess that this is also understood to all of you. Now let us see what does it mean one by one. This is actually human image captioning. Suppose that if I have an image and there is a cat, there is a dog, and there is some human who is wearing a red shirt over here. So image captioning says that, automated image captioning, that if I give this image to a network like this, which is being trained like this, which means to say that image and the output is going to be a text. which is going to describe the things which are there in my image. It can write that there is a man wearing red shirt and a cat and a dog, along with a cat and a dog. So this is the image caption, image to directly a caption that we are going to get. And for that, you can understand the input is going to be one value and output is going to be a sentence. That's why multiple outputs are there. Here you can say that a sentiment classification. Suppose that if I have got a tweet, so your tweet is going to be that Narendra Modi is doing well, and the sentiment is a positive sentiment. Then you will say that it doesn't matter to lit candles, it's a completely waste of time. Then you can say that's a negative or a medium level emotion. So it depends upon. So what you can say is that given any sentence, given any tweet, given any review, given any language words or sentence, can you tell me that what is its class? It may be positive, negative, it may be multiple different classes in which you wanted to somehow differentiate between them. So that is why it's actually one example of such type of many to one type of network. Many to one type of network is actually sentiment classification. Now, language to language translation, in which if I write in English, here English and here Hindi, I will say that I wanted to go. मैं जाना चाहता हूँ. Again, I wanted to go is going to be here. So first I see I wanted to go, and then once you are done, you are saying that मैं जाना चाहता हूँ. So you can see that the important thing is that this guy is connected to this guy, is connected to this guy. So that is why the context is actually being transferred and kept on learning. So if you predict something here or here or here, this context has actually seen all this stuff, what has happened till now, and what has happened till now, it understood and then started to tell you that what is the corresponding output. So it will convert language to language. It's actually called a sequence to sequence translation. And then many to many, this is also many to many. So instead of this, in which you say that first I listened to the whole thing and then I started to answer, you may say that I will started to answer it one by one. But usually in language translation, it is not happening, because in any language, it's not that for every token in one language, there is a corresponding token in the other language. Suppose that if there is a thing in which you have a token and its corresponding token is also available, then you can have one-to-one mapping from this. So from every input, you are going to get a single output. If that is the case, that is actually frame level video classification. So if I have a video frame over here, then the second frame over here, then the third frame over here, and this is having violence, this is having sports, this is having song, whatever. So you can say that if I show you image 1, then you have to tell me that what is its class. Then I show you second image, then what is the class, and why you want a relationship. Because if it is right now, because if suppose that this is a cricket video, then the upcoming many frames are going to be related to cricket. So there has to be a context. So that context is again kept on being building. So video classification is actually many to many. I will be leaving this thing and directly going to talk about yes, over here. So let us see that I'm having my input X, I'm having my output Y, I'm having a unit, recurrent unit, that I am saying that the RNN recurrent unit being placed over here, and there is a recurrent connection. That's why it's actually called as this actually a fully connected neural network, but it's actually having a recurrent connection, which essentially mean that whatever you are seeing, so it actually has a recurrent connection, means that I have a small amount of memory to remember, to understand that what I have seen till now. It is just like a small scratch pad, a scratch pad that you also have. Whenever I speak to you and you are listening to me, probably you may keep on writing few important things that you feel that they are important. So if I ask a question at any point of time, given that question and given the context or that small piece of paper, your both of these things are going to be used to give me the output or the answer, instead of the simple fully connected network in which you do not have the memory, you do not have that scratch pad, and still I give you a question and you just have to answer just via that question itself. So you cannot remember anything. So fully connected networks and CNN, they cannot remember anything. Recurrent neural network has small amount of memory associated to it. Soon we are going to understand that how these guys are actually working, and this guy is really performing. So we all understand that now what is xt? Xt is my input at any point of time, at any time t, because my input is now keep on changing. X1 is the input for at time equal to t equal to 1, then t equal to 2, then t equal to 2. So xt is actually the input at time t. This is the history or the state or the context, whatever you want to say. It is actually some small amount of memory in which I am trying to encode whatever I have seen till now. Whatever I have seen till now, I'm encoding it inside this, and this is actually the history at t minus 1 time. So you can see that my input at time t, my history at time t minus 1, and then I wanted to learn a function. What is this function? We want to say that this function is actually being parameterized over some parameter w that we need to somehow learn. We learn a neural network which is actually parameterized over w, for which is going to take input as these two things, and have to give me the actual state. What is the current state at ht? My state that into which I am going to be at time t. So it is just the previous state of Virat Kohli. This is the current input, and this is the actual state of Virat Kohli at time t. Now, whether Virat is going to give you a autograph or not, it is going to be dependent upon the current state, which in itself is actually being dependent upon its previous state and the current input. And that is the reason this is called as a recurrent neural network, because there is a recursive relationship which is existing. ht minus 1 is going to be somehow determined that what is going to be my ht. Now, once you have got the new state, how you are going to make my output, that is written over here. So 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 suppose that if I got my ht, suppose it is my ht, that's the my current hidden state or the current context or the current history. I learn another neural network. So here there are actually not one neural network, but in one recurrent unit you are going to have multiple neural networks. They are learning multiple things. I will talk about them. Essentially there are actually 3 neural networks. Before that, I am saying that suppose that I have learned a neural network which will take this value and going to give me the current state. Using this current state, I will pass it to another neural network. I'm passing this information to another neural network which is being parameterized over this w. And when I multiply them, which essentially mean that in fully connected network, if you remember, I have set of parameters and just have to do the matrix multiplication. So I am going to get the final output. Here, if you have till now, if you have any problem, then you can ask.
So Aditya, like
Yes.
if I don't have ht minus 1 value.
Yes.
So in that case, how does this recurrent neural network will work? Like if I have only new value and then how it is going to be? Can you give an example?
Yes. So every time what is going to happen is that h0 I am going to tell you. H0 is going to be the 0 vector initialized by 0. Is that okay? I am giving you h0 vector, and this h0
yes.
is just nothing but the initialization. If I give you h0, from h0 you can compute my h1. because you know
Right.
that what is X1 and you know what is H0. If you place it over here, you are going to get H1,
Mm-hmm.
right? So every
Yeah.
time, whatever you are having, the input and the previous things are definitely going to be there, because I am giving you the H0 initialized from 0. So every time you can compute H1, H2, H3, H4. H5 is going to be used to determine what is H6.
All right. Yeah.
Right? So every time you are going to somehow come up with the previous hidden state or the previous hidden vector or the history. Yes. Any other one?
Got it.
Any other question you want to? Anyone wanted to ask?
Sir,
This
in the
is,
context of
yes.
this coronavirus, how we can correlate?
Yes, we can correlate in this way, that suppose that let us talk about this coronavirus, and suppose that there is a trajectory which is going to be something like suppose that something like this, and hopefully Indian trajectory definitely have to be something like this, and it got widened and also got degraded after some amount of time. Suppose that we are at this point and we wanted to know that what is going to happen in the coming days, right? So the point that we wanted to somehow understand is that this value, this value, this value, this value, and keep on somehow shooting at some point of time, and then suppose that it got reduced. So we, at this point of time, if you wanted to know that what is going to happen over here, if it is very far from the current day, the prediction will also be that much, not that much accurate. But assume that you wanted to know that what is going to happen over here. So this actually says that what you have seen till now, there has to be a way in which I have encoded, and that is what I am saying, that I have encoded it in my HT minus 1 up to this, and along with that I am having my input. This is my XT. So this is my XT which is going over here. This is my HT minus 1 which is going over here, and along with that, for this current day, today, we have got that what is the HT. Now if you give me the HT, I multiply with my another set of weight vectors that we are learning, which will convert this HT, which is actually being multiplied over here, and that is going to be the next day's prediction, YT. And why this is going to happen is that what you have seen till now, it's somehow being encoded over here. What you have seen today, it is actually being here, and both of them are going to determine that what has to be the history of my current day, and the current day history is going to be somehow determining that what is going to happen tomorrow. This is the whole philosophy behind a recurrent neural network. If you want, so you can ask any other thing, because I assume that if you wanted to ask, I can answer it in that possible way. If anyone else wanted to ask any question, I can design it according to you, because this is a very widely used network, by the way, very widely used. Any type of time series forecasting, any type of any type of thing in which you are having dependence, previous things are going to be dependent upon the next day. Stock market prediction is happening via this type of network.
But in coronavirus, if you look at 2 days back,
Yes.
at a situation it got changed, right? So how we
Yes.
can predict based on the situation, like Marcus issue came and it's suddenly up, right? So
Yes.
here, how we can predict this one? Because the last 10 days, if you look at, the average increment is there, right?
Yes.
Suddenly it's gone up in, I can say, the 50% or 100%.
Yes.
Right?
So let me answer it in this way, and it's a very good question. So first of all, we need to understand that any type of time series prediction, if we are doing, we have to understand that if there is no stationarity in your data, if there is no predict pattern, if there is no proper pattern which is there in your data, then most of the time it is very difficult to somehow understand that what is going to happen next day. But let us see, and that is why we say that in when you are going to predict, instead of looking for 1, 2, and 50 or 30 or 100 days, you should be looking for 5-year data or 10-year data or 20-year data. So that is why COVID prediction, if I say, it's not going to give us a very, very strong, performance, very good performance. But suppose that we talk about the rainfall data. Suppose we have last 50 years every day rainfall data of a particular place, then your prediction can be very good. If you have a particular stock and for 50 years you have tracked that stock, and then you want to say that how it is going to perform, in that case probably you can say that yeah, in between that stock holder, sometimes market got up, sometimes market got down, but this stock prediction will even work during those times as well, because what will happen is that because that company was good, so whenever the stock goes down, it invests its own money and gives some amount of reliefs to the others, so that the stock price is somehow being reduced or not reduced or whatever. So in case of coronavirus, I just give you another example that it can predict, but if it is some markers is happening, or you say that some specific event has happened, maybe someday temperature becomes very high, and because of that the effect of corona is getting reduced. So these things, if suppose that along with your input data, that is that what is the previous count, if you are also providing that is there any communal violence, that is 0 or 1 vector. If you are giving that what is the temperature today, if you are giving that specific community wise, if you started to say that what is the community which got mostly harmed in the previous day, so your input vector has to somehow ensure that what are the variations that you are looking that are going to affect your outcome. So that is my point, that your X has to somehow be capable to hold all those information. Otherwise, anyways, Markers is not going to be learned by any model.
So basically, some are the cases we can avoid these theories, right? I mean, COVID is just one case, right?
Yes. But my point is that even with the COVID, so that's what I've said, that if you enrich your input vector in a way that at some point of time, that suppose that you say that I started to look with a specific community, that this community has got infected. Suppose that a specific community got infected at some point of time, and that information is also in my XT. This XT is not only the previous day infected count, previous day count, you are saying that the count, then the community wise count, then temperature, then amount of money that got invested in the last 2 days, and then maybe a number of foreigner travels coming in, for foreigners coming in India last day. So if your increase or have a proper input data for this, then probably those things can also be somehow impacted. And first day of markers may not be impacted, but for the next 2 days and 3 days, your model will be able to understand that, oh, this has happened, and because of that a specific community started to be somehow affected, and because of that the whole count is somehow going to be incremented. So this recurrent neural network is not going to predict for the first or the second day, but maybe at some point of time it understands that, oh, Maharashtra is the worst affected place, and continuously updating values like 20, 50, 100 every day. So it actually understands depending upon your input. If your input is not that much open, if your input is not that much informative, then it is not possible for a network to understand.
Got your point.
Got your my point.
So
okay,
I think railway and flight reservation, if you take this example will
yes.
be good, right?
For even for the railway, suppose that's what I'm saying, that everything depends upon your feature engineering. What is your input? If suppose that input is going to be a very simplistic input that you are giving, then it is not very not possible for any network to learn that what is going to happen. Probably it may start to give you some random jumbled values. But suppose that for the railway prediction, you wanted to know that today how many persons traveled, and tomorrow how many persons are going to tomorrow how many persons are going to travel. So for that, you just have to not being given the input, Along with that input, you also give that, oh, is there any previous, in yesterday, is there any important festival which was being there? Is there any 15 August, 15 August and 26th of January, these things are not being there. Is there any big bazaar sale is not going to happen? Is there some cricket event is not going to happen in Tamil Nadu? You suppose that in Tamil Nadu cricket match is going to happen, then the number of passengers who are traveling towards side is going to be high. So your X input is have to be somehow properly engineered according to your prediction task. If your input is being properly engineered, I am sure that, and if you have good amount of data, definitely using 5 or 10 day data, if you predict, then things are not going to work. Recurrent neural network require good amount of data to somehow predict. So if you have good amount of data, you train it over Wuhan. One can train it over Wuhan's, the whole abrupt type of things which has happened over there. And if you have a very enriched type of data, X vector for every day, probably you can somehow come up with a model which will take Indian data, which few amounts of tweaks can somehow predict that if it happens in Wuhan style, then what you are going to somehow predict that what is going to happen tomorrow. What till now what I have seen is that several persons have used multiple statistical analysis in which they assume that suppose that the Gaussian was being followed over there, then if the same thing happens over here, then that's actually a fixed function. They have not learned. They just have seen that if the same distribution exactly being replicated here in India, then what you are going to see tomorrow. So that a type of statistical analysis is there, but learning have to have a good amount of previous information possible. Now, feature engineering is very, very important. That what is going to be your feature? I assume that COVID-19, if we take all this data from different countries which are coming and somehow learn, then probably up to plus minus 10 we can learn that what is going to happen.
Yeah, correct.
Yes.
So I think, sir, these kind of data, at least it can help to predict, let's say if there is a country where there is no COVID case, so
Yes.
it can be, all these data can help to predict if it is going to happen there or not.
So yeah, so they happen there or not is like a classification problem in which you take any information and give it to your network, and your network is going to instead of predicting that what is going to happen, that we have said that instead of giving many to one, we are giving in fact one to one. So if I give you today's, what is going to be my next day, today's, and what is going to be my next day thing. So here, this is actually prediction, time series prediction, and this is like classification. So if you give me previous days information, probably I can tell you that whether this type of erupt is going to happen in that country or not. So that is why I have said that multiple types of models are being there.
Got it.
But the internal recurrent unit or the RNN remains to be the same. RNN remains to be the same, and one should have to really understand one simple thing about this stuff is that our assumption. What is our assumption? Our assumption is that there is some recurrent information is there. Recurrent information that what has happened till now, it is going to be impacting that what is going to happen tomorrow. That is why this is my today's data, that's my previous day's history. Using both of these stuff, I am learning a network that can tell me the current history, and using my current history, I am going to predict that what is going to happen tomorrow. That is the concept of RNN. Probably you may come up with any other type of concepts. They are anyways being there, and we will talk about 2 or 3 different types of models which are better than this recurrent, or one can say the modified version of this recurrent neural networks. So right now it is that this and this is going to give me the next day's history, current day's history. With the current day history, I am going to learn another network which will take this current day history and convert it into my output that I am looking for. Is that okay to everyone? Yes.
Hello.
Yes, please ask.
So it doesn't require much data. Then it will run everyday data.
Yes.
So it doesn't require that much training data.
No,
Like
no,
in
it
like in COVID case, we don't have much data available. So is there any machine learning algorithm available? Like I don't know, RNN is so that
yes.
it can learn. It can take the data every day and learn. And again, it will tune the algorithm. Is there anything where
Yes.
we don't have much data set available? The use cases like COVID and other might be there.
Yes, so that's what I'm saying, that see, if it is per day data, if I
Yes.
talk about everyday data, then COVID has started in November, and November, December, January, February, 3 to 4 months, and then it's actually 120 time steps. 120 time step is actually a very small amount of data, and your network will not be able to properly talk about anything which is going to happen. It's going to give you something random. But suppose that if I talk about everyday data instead of that, every hour data,
Okay.
and then you can talk about every minute data, and if I do it for every minute data or maybe every 30 minutes, then probably you are going to have good amount of information. Then instead of one time series, instead of looking this data into one time series, if you see this data in multiple time series, one time series is for China, one time series is for America, one time series is for India, one time series is for Spain, then you have multiple time series. Then you can talk about that within India, I am talking about the time series of Maharashtra, I am talking about the time series of uh, you know Madhya Pradesh. I'm talking about the time series of Uttar Pradesh. And then what will happen, that if you wanted to know that what is going to be the India's next tomorrow's count, you learn multiple models and independently for each and every state. Now Himachal Pradesh COVID count is variation is completely different from Maharashtra's variation. If I aggregate both of them and learn only one model, performance will not be very high because there is huge amount of variation. Instead of that, I started to learn one model for each state, and hourly basis or maybe 20 minutes basis, maybe 15-minute basis, I learn that what is going to be my next 15-minute information, and keep on adding for that zone or for Maharashtra. And then for all the states, if I add, that information is going to tell me that whether it is what is going to be my final India's next day count. So all these things are actually being, that's what I'm saying, that yes, as you are correct, completely I'm agreeing that if I train multiple models and just a small amount of data, it is not going to perform very well. Because our data of COVID is not that much high. But if we have good amount of data, the performance started to become as, I mean, very accurate as possible.
Okay. Thank you.
Yeah. So, but my only point that I want to make is that whatever time series that we are having, everyone is, aware of this COVID and all, but any type of time series, this is the neural network, recurrent neural network. When I started, several persons were actually asking that if I have a data, text data, language data, this data, audio, you can somehow predict if I'm saying something, what is going to be my next word. The same network is going to be addressing that stuff. So time series information, recurrent neural network is going to help us. Now let us see that there are not only one neural network, there is one recurrent unit, and this is the thing that one should have to understand. We have one recurrent unit, only one recurrent unit. One recurrent unit is having three neural networks: neural network number 1, neural network number 2, and neural network number 3. I am having neural network number 1, which I am saying that WHH. This is actually a set of weights that one should have to learn. I am having WXH. This is again certain set of weights that one should have to learn. And I have a WH comma HY. This is again a matrix, certain set of weights that I need to learn. I need to learn 3 set of weights. And how these 3 set of weights are going to work for me and going to give me the output, I take, so let me draw it in this way, that I have got a neural network 1, this, I have got another neural network 2 like this, and I have a neural network 3 like this. And how it is going to happen, I take HT, give it to my neural network, and you are going to get something like this, which is being like this. If I take xt, show it to my neural network, you are going to get something like this. When you have got both of these, you add both of them, apply some activation function over that, you have got the ht. Now ht is going to be into my third neural network, and you are going to get something like this. That is actually your yt. So what are these three neural networks? First neural network, so actually h is for the history, x is for the input, and y is for the output. So whenever I say that wxh, it actually means that it is taking input as something as x, and the output is going to be something which is compatible to some history. So what happens is that your input is in some input space, and it's actually a vector which is talking about the input. I need a transformation, a matrix which can take a x type of thing, x type of vector, and convert into a h type of vector. And that is why we have trained a network over here. This network is going to take something in the form of xt, and it is going to convert it into a something which is actually seen as wxh multiplied by xty, because this is actually a fully connected network. All these networks are fully connected network, n1, n2, n3, all of them are fully connected. That is why these networks can simply be seen as the matrix multiplication. And this xt got multiplied by this neural network. This is actually a weight vector, and you have got something which is a h compatible thing, history compatible thing. Now you have got another neural network. This neural network is hh, which means that whh says that I will take input which is something like my h and convert it into another h, history compatible. So your h is actually being transformed from ht-1 to a new ht, and this is my new ht. And then I add both of them. Why I'm adding? Because your current ht is not only going to be dependent upon your previous ht, instead the current input, so your current input is transformed in such a way so that it can be added to a type of history vector, so as to give you the next day history. So current day history, you have got ht, and then you have got another weight vector, that is why. It will take something as a history vector and convert it into a y, or an output type of vector. So the responsibility of this network, N3 network or WHY, is that to take something which is similar to my H hidden state, current hidden state, and convert it into some my output vector. So now you can again ask, this is a full details of recurrent neural network. If you understand, then it's very good. Otherwise, again I will explain. Please ask. I hope it's again clear. If it is clear, then it is very good. That if it got clear. So if we understand this stuff, let us now, one should have to understand that the meaning of a recurrent neural network. We all understand that neural network is actually being recurrent neural network is actually being consisting of three neural networks. First neural network, first neural network, then the second neural network, and the third neural network. It's actually consisting of three neural networks. Now let us see it one by one. So this is my neural network, which will let me show it to you. And this is my W thing for you, and this is my H0, the initial hidden state, and this is my input vector. So initial hidden state, my input vector goes into my weight vectors. I just have shown it to you. That was FW, assuming this FW is actually consisting of this as well as this. I'm assuming that this W is a set of weights which has been comprising both of these neural networks. So X and H0, X1 and H0 both are going, you are going to get H1. Then H1 and X2 both are going, you are going to get H2. And similarly X3 and H2, H3, and so on. And at last you are going to get HT. A very important thing I just have shown. First of all, this is called as the computational graph, or if I say this is called as the unrolling of RNN. Unrolling of RNN. What is the key thing which is being shown over here? The key thing is that if you all can see that this actually the weight vector W, it is actually being shared. Weight vector W is actually being shared. We are not having for each and every step the weight or the weights of my neural network, they are being fixed. W is fixed. W is not changing. W is not changing. Same W, if I place it over here, this is my W. And each and every, whether it is X1 and H0, same W's are being used. Whether it is X3 or H2, same W's are being used. Yes, so this W is here, this W is here, the same W is being shared for all of them. And the simple thing is that when your X and H0s are going, you are going to get this, then your this thing and this thing is going, you are going to get this, then your this thing and this thing is going, you are going to get this. Along with that, if you want an output, please check that from this H1, you can easily get Y1. From H2, you can easily get Y2. How? Because there is another neural network which is being placed over here. You just show that neural network your H1, you are going to get your Y1. The same neural network is actually being shared. The way this W is being shared, same neural network is also being shared for this output. Converting your history to your output, there is again a neural network, history to output, that was actually W history to output. And this is actually being shared over here, shared over here, shared over here, shared over here. So whenever you have got the current day history, you want to know that what is the output, you just have to pass that current day history to this neural network, you are going to get an output. So once you have got this output, then this is your output, and there has to be a Y1 ground truth. That what is the actual thing, what is the, because right now we are training. So for X1, we know that what is the actual ground truth Y1. So what is the loss? My loss is actually a function between Y1 and Y1 GT. Then what is this loss? So for every time step, you are predicting, and once you predict, then what was the actual thing, what you have predicted, because you know that what is the trained data, over trained data, you know that what is the actual prediction. So here your function, your loss will be Y2 minus Y2 GT. So if you are doing regression, then probably you are going to get MSE type of loss, in which you see that, oh, COVID count was, my prediction says that it is 510, but actually it was 503. So then you will say that the value is that my difference is 7. So MSE is actually going to tell you that what is the difference between them. And if it is not regression, if it is going to be the classification, then the last layer is definitely here you are going to give me the probability distribution of each and every class, and then what was the actual class of that object, 0 0 1 0, because one hot encoded actual class, and then you will find out the cross entropy between them. So let us see it. Yes, so let us see it once more, that your X are going in this way, your hidden states are going in this way, your outputs are going in this way, your losses are being computed like this. For each and every step you have got your loss, and your total loss is that adding all of them, that each and every time step what was your loss, and that is your total loss. Once you have got your total loss, you find out that, so what are the weights that you are looking for? We are looking for that set of weights which can minimize my loss. So what you need to do is that del L by del W. This is the thing that we are looking for. So once you know that each and every loss, so you wanted to know that if I tweak slightly my weights, then how my loss is going to be varied, reduced or increased or what. So that is the thing every time. That is actually the back propagation, which is anyways going to happen. So soon we are going to see that. That's actually many to one. In many to one, we wanted to say that maybe you are not interested to find out output at each and every location. For each and every time step, you are not interested. I am showing you the full sentence. I am happy by the efforts of my government. What is the review? Review said it's a positive. The movie was very bad. The output is negative. So instead of giving for each and every word what is the review, what is the sentiment or the class of my review, I will say that first listen to the whole thing and then give me your final verdict that whether it was a positive review or the negative review or what. So that is actually why this is called as many to one type of network. Now let's see that one to many networks. So why one to many network means to say? One to many network means to say that I will give you one input and then you need to give me multiple outputs. If I give you an image, you just have to tell me that it is having a cat and a dog and a car and a bus, and there is a man who is walking on the street along with a dog. So that is actually image captioning. So that was actually the answer for our one to many network. The same way this thing is going to happen. The interesting thing is that I will add. So I have shown many to one and then one to many. Many to one, you all understand, many to one. And then one to many. If I add both of them, you are going to get many to many. How? This is your many to many, in which first I am having a many to one and then I am having a one to many. If I add both of them, you are going to get a many to many, in which first you see all this stuff, the whatever the hidden state you got, that is being passed on to the one to many network, and then you have got this output. So this is actually many and this is also many. So sequence to sequence translation, sequence to sequence type of translation, in which you have something written in English, you wanted to convert it to French. These type of models are actually being trained. The important thing is that these are different ways in which you need to design and train your models, but RNN remains to be the same. RNN remains to be the same. I just have talked about this recurrent neural network or the RNN unit. This is single RNN unit. If I say, that can be seen as my single RNN unit. We do not have multiple. Right now we are only having one single RNN unit, which is being unfolded in time. Why this is one? Because weights are shared. Only one set of weights are there. There is not a second set of weights at all. There is only one set of weights, and the same set of weights are actually being used, no matter you are showing it x3 or x4 or x5 or x7 or x50 or x10. For every input, the same weights are actually going to be used along with the previous hidden state, so as to get the next hidden state, and using the next hidden state you can predict that what is going to be my output. What is going to be my output? Now we are going to talk about a very simple model that is going to predict the next word, character, next character, not the word, next character. That is actually called as the character level RNN. Character level RNN is going to be trained in such a way so that I will first have huge amount of data in which Shakespeare has written the whole stuff. So all the Shakespeare's data I have taken, divided into training and testing, and over the train, multiple sentences, paragraphs, whole book I have shown to a network, but character by character. First I shown first character, then the second character, then the third character, then the fourth character. And once you show a character as an input, hidden state is definitely going to be maintaining that what I have seen till now. But your objective is that if I show you one character, you have to tell me that what is my next character. So obviously where your network is not trained, you show first character, you are going to get something which is completely wrong. Then you have got your losses, and you keep on training. After some amount of time, your network will started to understand the different possible spellings which are being there in your data, because because character level RNN can understand that what is a spelling. If I show you vocabulary as a word, then at some point of time you understand that the spelling of vocabulary, because after V you are going to say O. Why? Because it's actually going to be the vocabulary. So your network is being trained in the example that I'm going to cover. The network is going to train a character level language model. Character level means that I am going to see my data one character by one character. One by one, I'm going to see my every character. Now let us see a very simple thing that one should have to understand is that I am going to train my input sequence and the whole training data. Input sequence and whole training data is only having one word, that is HELLO. So if there is only one word, usually it is not going to be the case. You are going to have thousands and millions of words which are going to be there, over which you are going to train. Just for our understanding, we are going to use only one word, that is hello, HELLO. What are the total vocabulary that you are going to have? My total vocabulary is HELLO. Only 4 things which are being there, because L is being repeated. If only 4 things are going to be there, if you all understand that one hot encoding, so we all have to understand that if it's actually a character, then there has to be some mathematical mathematical encoding that my network can see. My network cannot see H or E or L or O. It can see that H is different from E, which is different from L, which is different from O, and there is no relationship between H and E. They all are H, E, L, and O. They all are independently and identically distributed, which means that we are going to use one hot encoding for H, E, L, and O. So suppose that my H is going to be first value 1 and all are 0. E is first value 0, second value 1 and all of them are 0. Third one and all of them are 0. And third one and all of them are 0, that is L. That's my input characters. Why input character? First I show H, then E, then L, then L. And what I am expecting that here, H you are going to give me E. Here you are going to give me L. Here you are going to give me L. And here you are going to give me O. Is this okay to everyone? You can ask in between.
I'm fine with this, but this is also an example of RNN model.
Yes, this is also going to be an example of RNN model.
Okay. But if that is the case, like why they have said again the character level language model? So RNN, we are giving many to many or one to many, or the next based on the previous history, it is going to give the future predictions.
Correct.
So this is the one type of model where we are playing with, like we are applying on a characters so that it is giving the words.
Yes.
Is that correct understanding?
No, here we are going to show one H or one character at a time, and network has to tell me that what should have to be my next character.
Okay. But is there any other? Is there any other model like it will give like I'm just taking one in Word, like when we are typing like a H, it may give like multiple words also, right? Like starting with a H. So I think for that we'll have another model.
Yes. So that is actually that if you wanted to train it for word level and auto completion, I guess that you are talking about auto prediction, auto completion. Yep. So auto correction, auto completion can also be done, but for that you have to train not at character level, but at word level. So suppose that if I say that hello world, this is me, then for hello I need to come up with encoding, for word I need to come up with encoding, for this I need to come up with encoding, for me I have to come up with an encoding which is going to be suppose that 1000, this is suppose that 0100, this is suppose that 0010, and this is suppose that 0001, and then the same model can actually be trained.
Got it. Yeah.
Got it. Yes. Okay, fine. But right now it's going to be that if you type H, then it is going to tell you that what is the next character. Okay.
Yes.
Yes. And actually it can generate the whole text for you. You just have to tell me one character H. it will type the whole thing. First, it will generate HELLO and then can write the whole letter for you.
Right.
So soon we will see
But
that how this thing is. Yes.
but in the
Please ask.
coding, I think we are not going to there will be some functions to implement this kind of models, right?
Yes, yes.
I'm just,
Single
yeah,
lines. Single lines are there. One line is there.
okay.
And soon in
Mhm.
our next class, once I am done with this, modeling and the theoretical stuff, and then Daksh is going to cover that RNN recurrent model. You all will be training this stuff.
Oh, got it.
Okay.
Got it, yeah.
Fine. So, yes. So let us go. Yes. Let me draw the whole thing for you. Yes. Let us see how it is being trained. Let us go slowly one by one. That first, this is my input. It is going into the hidden layer. And if you all understand that hidden layer is actually having two things. What are those? WHH and WXH. And X will, this is my input. X will go into this, and this is my hidden H0, which will go into this, and you will add both of them, apply 10H, you are going to get this information. Once you have got this information, there is another hidden, neural network, that is HY, and you take this thing and give it to this network. That's going to give you the values like this. Once you have got your output like this, you find out its distance with the actual thing. Actual thing was E. You are expected to have what thing over here? You are expected 0, 1, 0 and 0. You find out the loss between them. Once you have got the loss between them, then you keep it over there, and then you show E. Your E is going to be like this, and then you will show it to your network, and you all understand that the same network, same weight vectors are going to be used, and let me show that this value will go over here. This vector, whatever the previous thing that you have got, which is right now the H1, will go over here, and you will got a value which will come over here, and using that information, which becomes H2, you apply and pass it to the same this thing, and you are going to get this thing. And the what is going to be the current, so what you are expecting after E, you are expecting L. When I show you E, you need to tell me L. L's output should have to be 0, 0, 1, 0. And then you find out the loss. And then you feed your L. And once you feed your L, L is going to be here. And this hidden vector, the new hidden, previous hidden vector will be going over here. You are going to get an information of H3 over here. H3 will be going here. You are going to get this information. Do you understand the flow which is happening inside this network? If you understand the flow, then I move forward. Is there any question related to the flow? Yes, flow is okay to everyone. Then, so this was actually the training. So for each and every step, I have got the losses. I add all of these losses, loss 1, loss 2, loss 3, loss 4, all these losses got added, and I need to back propagate them. How? I need to back propagate them in such a way so that this and these what should have to be these weight vectors W, H, H, W, X, H, and W, Y, H. What this should have to be, so as to get my loss as less as possible. That's why we differentiate my loss with respect to them and get the updates of these loss, update them, and got the next losses, and keep on training my network until I started to get the best possible results. Once you are trained, you have got the full network. How you are going to predict? How we are going to predict is this. Let us see it again. Your input is going to be this. Your network is fixed, which essentially mean that you have got W, H, H, you have got W, X, H, and you have got W, H, Y. So if I say that my network is trained, I have got these three values. How it's going to happen is that this guy is going to be here. Sorry. This guy will go here. the hidden state, this previous hidden state will go here, and you are adding both of that stuff, and you are going to get something over here that is going to be here, and you are going to get this output, and then you apply softmax because that's my output function. We have to somehow normalize, and that is going to tell me that you have E. If you say that I have got an E, that is going to be sent to my input, because at training you do not have anything other than the input, first input. I am while testing I'm only giving you one input H, and then you will have to tell me that what is going to be the upcoming characters. So this is my next character being predicted by H. The same thing is being sent as an input to my same network again, and all again understand that I am having three neural networks. This guy will go here, the previous state which becomes the next state will go over here. Add both of them, you will get this, and this information is going into my YH, and you will get output like this. Over that you apply the softmax, and then you can see that at every step, if I show H, you are going to give me E. The same E is actually being fed as, or whatever E or whatever the input that you have generated, it's actually being fed in my network. I have got another output being fed into my network. I have got another output being fed into my network, and you keep on generating infinite amount of time. Whenever you want, you can stop. Whatever things that you want to generate, it can generate the whole text. You all understand this stuff?
Yeah, Praveen, I
Yes.
think we are getting a background voice from you. Can you go on mute, please?
Yes.
Yeah.
So anyone can ask if you are okay with this. Okay. So now we are going to talk about two simple things, and then probably we will finish the session. First one is the back propagation through time. This is actually back propagation through time. What does it mean? Is that this is my whole input. This is my whole input. This is my X1, then X2, then X3. I am having X5K. I am having 5K characters in my whole text. I show them one by one, and my hidden state keep on changing like this. This is my H0, then I have got H1, then I have got H2, and keep on doing, and then I have got H40, 499, and so on, and then you have got the final state H5K. Using H5K, I can generate my final output. For each and every output, I have got a loss. I add all of these losses. I'm adding all of them. If I add all of these losses, that becomes my single loss, and then I take a derivative of this loss with respect to the weights that I have, and then back propagate. Now, if we do it in this way, then for single update, one simple single update of my weight, if you remember that optimizers that we have talked about, a single update, the same optimizers are going to be working over here, but the only thing is that my single update is going to happen once I have seen my whole data once, but it is going to take huge amount of time for a single update. That is why, first of all, let us understand why this is back propagation in time, because everything is being back propagated like this. And now you can see that things are being back propagated and being back propagated in time, because this is t equal to 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's why it's back propagation in time, first of all. But if you take first see everything and then only back propagate once, then only one update is going to take huge amount of time, and you need to update multiple times to get your best possible weights. That is why we used to do it in truncated back propagation in time manner, which will say that first I will see only up to this, only up to the say first 10 characters. First I see 10 characters, I will find out my loss and then back propagate. Then I see my next 10 characters, find out my loss and back propagate. Then I see my next 10 characters, find out my loss and back propagate. While I am back propagating, it will only be back propagated up to the previous step up to which we have done that. So that is actually back propagation through time itself, but truncated, because we have truncated it in steps of say 10 or 10. So if this is actually like that, you are not showing the whole data at once and then back propagating. I take the whole data, divide into chunks of 5, 5, 5, 5, and we say that that is my iteration. And after every batch, that's my one batch, I show one batch, find out my losses, and then back propagate. That is truncated back propagation through time. Once we are done, this is actually the code. Maybe in the upcoming lectures, our lab, Daksh is going to talk about this code at some point of time, that character RNN, or maybe something else. He will talk about this RNN we are going to cover in our lab. This is one code that I just have, I'm not going to cover this code. I just have said that the whatever I have covered till now, each and every step is actually being written here and being given as a code in the form of this code, which is being available here in this Carpathy's GitHub slides as well, GitHub place. So you can download, and if you want to run, then you can run as well. I'm going to talk about that if we have trained our model, and if I show the whole William Shakespeare's literature to this simple single RNN, how it is going to perform. So for initial few steps, after training for say 1 hour or 2 hours, probably you are going to get stuff like this, which is not a jumbled RB type of thing. After training more, probably you started to get some information after some amount of time. Maybe after training it well, you can see that it actually understands several relationships, that if there are some quotes, then there has to be closed as well. If there can be a comma, different commas like this, it can understand why is a word, do is a word, replied, wishing, himself, fact. Spellings becomes correct, started at some point of time, although the semantic meaning doesn't have much information. Just read it. Why do what that day, replied Natasha, and wishing to himself something. It's actually not having any meaningful information coming out, but actually it's a character level RNN. So it actually understands that what has to be the character sequence which is going to come up with some meaningful words. So that is what this network has understood to somehow talk about and predict. Any questions till now? Because this is the part that I wanted to cover, and maybe in the next lecture we will cover the advanced recurrent neural network architecture that are actually being called as the gated recurrent unit, GRUs, as well as LSTM, long-term short-term memories. Anyone want to ask anything? Then please ask.
Sir, I have a couple of questions.
Yes.
Like how we can predict, like whatever the voice related, suppose we need to predict somebody as is speaking, and how we can calculate their vocabulary, fluency, a kind of concept. So what is the concept for to implement these concepts? I mean,
yes. So before going to answer this, let us see that what is going to be your objective: speech recognition or
yes. No.
speaker identification?
Speech calculation. Basically, my requirement is there. Suppose, take an example. I am hiring some guy who is a work in BPO. Okay. So I want to test their fluency, vocabulary, and so on. Right. So
okay.
This is suppose this is my question. So how we can apply this concept on that? How we can get a score, basically?
Yeah, this is interesting. So assuming that you want to check that if the guy who is speaking, how fluent he is, how different words he is using, how unique word he is using, how not uncommon words he is using. So I guess that you want to check that how well he is in English conversation. Is that the correct thing?
Certain extent, but let me rephrase my question. Suppose I am running one recording file, which is a perfect. Okay. Now I told this guy to speak same whatever the recording file is speak, same you need to start, and I need to judge how many mistakes he has done, and vocabulary is right, fluency is right, kind of calculation. So some kind of a score I need to generate. based on the recording file. Number one. Number two, if I tell anything, say, tell me about yourself. So I need to judge what are the word he spoke, is the right or wrong. Does that make sense, my question? Hello?
Yeah, I think we can hear you. Aditya, are you there?
I don't know. Can you listen?
Now I can hear. Now we can hear you. Yeah.
Oh, I guess that some disconnection has happened.
No problem.
Yes. So yes, you were saying something. Please complete. I missed.
No, I want to, I mean, whatever the, okay, I have two questions. One,
Yeah.
if I'm running one recording file, and if I'm telling candidate to follow the whatever the recording file is speak, right?
Okay.
So when you start copying that voice speech and whatever is starting to telling, so I need to judge their scoring. I mean,
Okay.
how many? Suppose 10 sentences he spoke, then
Yeah.
I need to calculate. Okay, vocabulary is correct or fluency. What is the fluency and kind of thing. So
Yes.
how we need to do that using this concept?
See, so in that way, we will have to somehow design that why that we are learning. Why should have to be, first of all, for each and every sentence, whatever he is saying, we have to have a ground truth that what why should have to be. Suppose that fluency, then for every word, what is the for unique word or what is the correct word. So probably we require uh, uh, a way in which we can say that what is the ground truth for each word. So we know that this guy is speaking in English, and 10 sentences are written. So 10 sentences are anyways written, and we know that what is the ground truth for each and every time step, that what is the ground truth. So one can check that if he has said anything, then how far it is from the actual ground truth. So in that way, probably you can check that how correct he is speaking. Then about the fluency, if you want to say that, we will have to somehow think that how can we digitize the fluency in terms of feature, because it's going to be a slightly, concept which is abstract, that what you say that it's fluency. Some person may be very fluent, but may be saying something completely wrong. He may speak very fast, but speaking very wrong things. I mean, speaking in a wrong way. So we will have to actually decide. So this can actually be seen as a research problem, in which for each and every sentence, and for each and every time step, we will have to come up with a vector, four dimensional or 5-dimensional vector, in which one information is going to say that how correct he is, second information somehow has to say that how fluent he is, third information is going to say that how well he is going to capture the previous context, how unique words he is using. So probably my point is that in that scenario, we will have to uh, make ground truth for every time step in the best possible way, and then we can train. But although I guess assume that's actually a good research problem, in which given a specific sentences that we have, and a person who has speak already, the second person is listening to it, and how well he is with respect to the given actual information or the given actual input audio.
Great, sir. So should I, okay, so what the original file, suppose I am comparing,
Yes.
what the original file is there, it's running for 30 seconds, okay?
Okay.
And we are telling to student, okay, you start copying this, whatever they speak about that. So should I calculate first what the original file score is there, then we compare with the student scoring? Is that your thought is there?
See, yes, that can be one way. You have a benchmark. Along with that benchmark, you will say that what is the value of the original recording first of all, and then you say that how well a person is mimicking that. The other thing is that you assume that whatever the benchmark that you have currently some English person has spoken. So given that, how well this guy is, with respect to the given input, what is how well this guy is performing. So that is actually the benchmark become itself. The benchmark becomes that audio itself. So both of these things can be possible, but I assume that benchmarking already being said something is a bit more complex. Instead of that, what you can think of that given English person's English accent audio, how well all these other students are performing, how well they are, how close they are with respect to the given audio input. I guess that is a good way to do that.
Hello.
Yes.
Hello. Can't we go like this? Like first we'll take the interview and
Yes.
we'll manually prepare the data and we'll label the data. Okay, this recording was selected, this recording was rejected, and we'll give this data to the network. Network will only identify, okay, this recording was fluent, and prepare the weight. And whenever the new candidate will come, and
Yes.
like a testing data,
Yes.
it will go to the network, and the network only will tell, okay, it is going to be accepted or rejected.
Yes, so that's what I was trying to say, that for every data we will have to talk about the as you have said that accepted or rejected. In that, what you have said is that for listening to the whole recording, so that is many, and one output is going to be one. So that is actually a model that you are talking about, that is many to one.
Yes.
Then it can be a many to one model. We need to prepare data in that way. Then some person will say that no, instead of that, I wanted to do it for every sentence. I show one sentence and say that whether this sentence was well said or not well said. So it can be at sentence level. The third person may say that I made, and that is also many to one, because full sentence is actually many, and then it's going to be one. And then you can also say that for every word I am saying that how well you have said this word. So it can be word level.
Okay,
So
you are talking about the features. Okay, those will be features.
Correct. So it depends upon that how you can, and how low level you can come up with the ground truth data, because ground truth coming up with that amount of ground truth data is going to take good amount of time.
Okay.
So as you have said, for every candidate, first we train it in such a way so that if a person has said it in this way, then he is accepted or not.
Yeah, and the machine learning will identify which feature is important to get that candidate selected.
Correct.
So based on those features, it will prepare the weight or calculate the weight, and ultimately it will work on the test data the same way.
Same. Correct. Similar to that, things actually works. Yes. And that is why it is called a supervised learning. Till now, we are doing only supervised learning.
Okay.
Yes. Anyone else who want to say anything? No? Okay. So what we are going to do is that in this upcoming week, we are going to probably give you certain things related to recurrent neural networks and this our lab part. And the next Saturday, first I will try to finish something, and maybe then Daksh is going to talk about the implementation. Let us see. Okay.
Thank you so much, sir. Thank you so much.
Okay.
Thank you,
sir. Thank you.
Okay. Thank you. Bye. Okay. See you.
Thank you.
Okay. Bye.